Good day to all. My name is John Mark Torres, and I'll be discussing the introduction of water quality and management. What is water quality? Well, water quality is the condition of the water, including chemical, physical, and biological characteristics, usually with respect to its suitability for culturing aquatic organisms. Take note that it determines the success or failure of a fish cultural operation. Aquatic animals perform best when they are not subjected to stressful environments. Tolerance of a species has for water quality is to look at where in nature that species to perform best, such as tuna in seawater and tilapia and catfish that can be found in freshwaters. Also, take note that water contains a lot of ions, elements, chemicals, and compounds, toxic when present at a sufficiently high concentration. Sometimes more chemicals are present at a certain level, their potential for toxicity is actually reduced. Here are the water quality parameters based on physical, chemical, and biological characteristics. This includes temperature, salinity, light, turbidity, dissolved oxygen or DO, pH, alkalinity, ammonia, hardness, nitrite and nitrate, carbon dioxide, hydrogen sulfide, and lastly, heavy metal. We will tackle the first parameter, which is the temperature. Each aquatic species has a temperature range within which growth is optimal as long as other conditions are appropriate, sufficient, food of the proper quality is available. Take note the temperature should be minimal. Abrupt change by greater than or equal to 5 degrees Celsius is stressful or lethal because it is the most important physical factor to consider in aquaculture since it influences the aquatic environment. Here are the effects or influences of temperature. First, it affects the metabolic rate of organisms. Rate of respiration increases with increasing temperature, and dissolved oxygen consumption increases with increasing temperature. It affects solubility of gas. Solubility of oxygen is less at high temperature compared with lower temperature. It affects the stability of water column, which means that there is no uniformity of temperature in the water column. The non-uniformity of temperature in the water column is known as the thermal stratification or layering rather. Warmer water is at the upper column except when temperature drops to below 4 degrees Celsius. Warmer water is at the lower column. It influences growth of aquatic organisms such as plants and animals, including finfishes and shellfishes, at the ideal range between 27 to 29 degrees. Fish growth is accelerated with high survival. Lastly, it influences spawning and shortens the time of hatching. At a higher degree in the ideal range, spawning and hatching are hastened or accelerated. Take note that the temperature outside temperature tolerance limits between less than 21 degrees to or and greater than 35 degrees will impact stress and disease and eventually will cause mortality. Here are some factors that influences heat in water, such as dissolved substances, which compromises inorganic salts and organic salts, suspended particulate matter, fine particles suspended in water, and lastly, plankton. It maintains the quality of pond water and reduces the amount of toxic substances. But in a fish pond, the water temperature at the surface is equal to 31 degrees Celsius before the start of a bloom, and it becomes 35 degrees Celsius at the height of a bloom. From this, it could be generalized that the greater the density of plankton, the more light is absorbed at the surface, and consequently, much heat is generated in the aquatic environment. Second, we have the parameter for salinity. Measures the total concentration of all dissolved salts present in a natural body of water expressed as grams of salt per kilogram or of water, or the unit for measurement is parts per thousand, or ppt, and percent. Other than salt, we have other minerals such as calcium, sulfur, and etc. Here are various techniques or methods in measuring salinity. First, you have density. It is the least expensive. It records density and converted to salinity by employing conversion tables. Instrument used is hydrometer. Next is refractive index of seawater. It is the simplest and most rapid method. It directly measures the salinity of water. The instrument is refractometer, and it is quite expensive. Third is conductivity, the method of high precision. The device used in this method is much more expensive and yet requires a fairly large sample. It is useful more often to the researchers than to the aquaculturists. And lastly is titration method. This requires reagent solutions such as chemicals and is done in the laboratory with the aid of a burette, Erlenmeyer flask, etc. Please take note that the first two methods, which is density and refractive index of seawater above, are to be used when salinity is suspected to be high. Based from the salinity of or the PPT, we have classified each aquatic environment into three. First is freshwater, which has the salinity of less than zero point 0.5 parts per thousand. Second is brackish water. It ranges between zero point 0.5 to 34 parts per thousand. And lastly, marine water, which range between greater than or equal to 35 ppt to less than 40 parts per thousand. So we have factors that affect salinity of marine coastal water. First is rainfall. It's because it directly or indirectly reduces salinity. And then we have freshwater runoff. Freshwater runoff from rivers greatly reduces the salinity, and so culture sites should not be immediately adjacent to the mouth of the river. The effects of salinity. It affects solubility of oxygen. The dissolved oxygen decreases with increasing salinity, and vice versa. Second, it affects the osmoregulatory function of most aquatic vertebrates, including fishes. Osmoregulation requires a significant amount of energy to maintain the fish body fluids to counteract the effect of salt concentration of the habitat that may lead to mortality. And lastly, fluctuating salinity, especially a sudden change, a decrease or increase of at least 5 parts per thousand salt greatly causes stress or even death of the fish. That will be all. Thank you.